Hey guys, I'll be solving 3 sum today. If you know watched the last video, which is 2 sum 2, definitely watch that. Before this, I've given a hint at the very end that is basically if we are given the equation, we can convert it to this, and we have to use NLR, so the two pointers approach on a specific number. And in this question there's a bit of a difference, so we can't have the same triplet twice, right? And we can't, like, the indexes that we choose, they can't be equal. And so we're given this array, right? And what we're supposed to do is we're supposed to pick out basically 3 numbers that all add up to 0. And like I mentioned, we could basically have n, l, and r equals to 0. So the number we pick at the start of the thing, and then we run a 2-pointer approach, right? And it should basically sum up to 0. And I gave this hint at the end of the video, and it's basically l plus r can be turned into minus n as well, and we can rewrite the equation like that, makes it a bit more simpler. And the main thing is, like, the first thing you always want to do with 2 pointers, you have to consider if the array is sorted or not, right? And in this case we were given an unsorted array, right? But if we do sort the array, this question becomes much easier. So if we consider the same input, right, and we say this is -4, yep, -4, -1, -1, and then 0, 1, and 2. It is basically like the 2 sum 2, where it's every time we increase left, we're actually increasing our sum, and every time we decrease our right, we're decreasing our sum. And it's basically the same thing. So now let's consider we pick an element n, right? We're running through the loop and we pick this as our element. Do you think we should start off n at l and right here, or do you think we should start it 1 ahead of n? Obviously we want to start it 1 ahead of n, right? Because I already mentioned we can't have the same indexes. So we started at 1 after n, and it wouldn't make sense to even do that either, because why would you want n plus r? That's not the question itself, right? Now we'll turn our input to sorted, and we would get this, right? So this would give us O n log n complexity, basically. Now same thing basically as the last time. If we have n, we'll say -4 in this case, -1, and then +2, right? What does that equal? -5 plus 2, that's -3. Is that less than 0? Yes, it is. But I'll also go through I'll use the other equation actually, because I find it much more easier. We'll do -4 on the right hand side. So wait, I'll just show it to you. If you do -4, -1 plus 2 equals to 0, we can say -1 plus 2 equals to 4, and then we will see that 1 is not equal to 4 and 1 is less than 4. And what was the same approach in 2 sum? If we are less than the target we need, we'll increment our left pointer, right? Because we don't want to decrease the sum, we want to increase the sum if it's less than. And if we were, let's say, in the opposite direction, so 5 was greater than 4, we would decrease our right sum, right? And it's basically the same thing. And when it hits equal, now that we don't have one unique solution, which is in 2 sum 2, yeah, now we need to just append it, right? And given that they don't want us to have the same triplets, what we should be doing is, if you do find index, so let's say in this case it would be -1, -1, and then 2, that would give us the answer. And we would say n is this, l is this, r is this. We would cut off on both l plus equals to 1 and r minus equals to 1 once we get the triplet, because we don't want to be considering l and r again. We'll go straight in because we want to shrink it and we don't want to have duplicates. And that's basically it. So I'll just write down the code. It's a pretty simple bit of the code, and I'll also show the way to avoid duplicates basically. So if we sort the input, right, and we have some res equals to some empty list for now. Now, like I said, we'll traverse through the array, pick a number, and in this case I'm doing enumerate. It helps keep track of the index, right? Because our L will start necessarily I plus 1 basically. If we say n is the index, then L must be I plus 1. And I'll do enumerate. If you don't know what enumerate is, it's basically if you're given 0, 1, 2, 3, 4, and it basically starts from 0, 1, 2, 3, right? In enumerate, it would just be 0, 1, 1, 2, 2, 3, 3, 4. So this is the index and this is the number. That's how it will look. And that's basically the same thing. Now the way to avoid duplicates is if we're already ahead in the array, right, and we have to do, let's say if we're on number element second here and we see that the first one is the same, then we'll just continue because we've already done the first one, right? So that's the same idea. And the number we are on is equals to the number that was behind us. Then we can just continue. You don't need to check for this because we've already done it. Now, like I said, it will start 1 ahead, and r will always be len nums minus 1 because you want to consider the whole array, right? You don't want to consider only a part of it. And the same exact thing as last time, while left is less than right, if the L, guess I'll write it out properly, if the nums L plus nums R, oh yeah, and also set a target to minus n so that we can say target. If it is equal, then res dot append, and then just take all three of these, right? And like I said, we'll chop it off. So we'll chop off both the left index and the right index. We'll increase and decrease. Now another way to not consider the same in like the same value, we can simply do another check for duplicates. So if it is the same and we're going through the left, right, so it'll be the same logic as the one at the start, and nums is the same as the one behind it. Then we'll just continue, and the same way but on the opposite direction for right. So we'll decrease right, and we will check with the one that's ahead of it because we're on the right. We started here, and then we will come here, then we would check, hey, is the one ahead of me equal to me? And we'll just continue. We'll do these two until, well, L crosses the maximum and right crosses the 0. You could also do it with L is less than R, I'm pretty sure. Just have that condition instead of these two, it would still work. Now the next thing was, if let's say our nums L plus R actually came out to be less than target, then like I said, we would increase left plus equals to 1 because this is a sorted array. If not, we'll just decrease our right, sorry, and we'll just return our res at the end, and that's pretty much it. simple code, pick a number, do the 2-pointer approach on it, use the same logic as 2 sum 2, except this time once you hit it you don't return, you just shrink the array on both sides, and that's